Welcome back. Fine, so let me make you host so that you can handle the session.
Yes.
I think we can start the session. Already 11:49.
So, shall we wait for other? So we have 29 people.
This session will be over at around 1:20. Fine.
110. Yes, sir. Okay, so yes, sir. They are joining. Yeah.
Devilna, am I audible?
Yes, sir.
Okay, you can start the session. Fine.
Okay, sir. So just sharing my screen.
Yes, yes.
So is it visible?
Yes, yes, visible.
Okay, sir. So welcome back, everyone. Now we are going to learn some more concepts. We are going to brush up some fundamental concepts of programming. So in this session, I'll go through some concepts like variables and data types and how they are expressed in Python, and some more concepts such as how to write an if-else statement. And using that, I will also give you a short assignment which will be within this session, which you will code on your own to design a small calculator function for yourself. So all this implementation, it will take place in your Google Colab notebook. Before we begin this session, let's have a quick recap into whatever we learned in the previous session. So for that, we'll get back to our Colab notebooks. Okay. So I hope the notebook is visible to all of you. Thank you, sir. So here we have our first Python program, the first statement that we wrote in Python, which is hello world. And I'll also execute the code one by one so that you can follow along. So this is how we connect to the backend, the Google Compute Engine. And after we establish this connection, we are ready to use all the resources. So right now I can simply run this code. So we use Shift plus Enter to run the code cells. It is like a more effective approach. You can also use the play button over here to run the cell. So here we have the hello world. After that, we also learned some of the basics. Before that, we can also execute some command line code within your within these cells in your Colab notebooks. So you simply have to write one exclamation to signify that this is a command line. Statement, and we have Python version. So if you want to check which version of Python is available to us when we are working in Colab. So we have Python 3.7.13. Okay, not the latest version of Python, but preferably the version which they think is more stable, that is available to us. So we can execute this and Python 3.7.13. So this is how you can also check the version of other libraries when we are going to work with different libraries in Python. We'll see that. So this is your print statement, which we just saw right now. Hi, I'm using Google Colab. We also printed a greeting message. So we took our name and stored it into a variable called name, and we printed hi plus name. So this gives us a greeting message like here we have hi Debolina, my name. Just execute it. Yeah. So in the previous session, I also told you that we need to lay a lot of emphasis on indentation. So here Python uses indentation for blocks instead of curly braces that we have in other programming languages. So here we have one statement: if 5 greater than 2, print 5 is greater than 2. Let's execute it. Okay. Suppose I just omit this space. I don't have it and I want to run it. What will happen? Expected an indented block. So this is the error that you encounter if you do not have proper indentation within your Python code. And guess what? This is our first error that we saw in Python, right? So this is how you have error functions. These errors come up. Also, if you have line numbers available, then you can easily spot the error. Here we have very small code snippets. We need not necessarily use line numbers, but when you are writing longer scripts, then that will come very handy. You can directly go to the line numbers pointed out in the error message to resolve whatever needs fixing. Okay, we can also have different blocks of code. So there's something called as, we have for loops. Loops is used to execute a set of statements repetitively. So we write for I in range. So don't worry if you don't understand anything, right? Any of these keywords right now. We will go into loops in more detail in another session. I just want you to understand what indentation actually means. So just have a quick look. So we have this loop over here, and then I want to print. I also want to have another statement. Here I want to have I plus 2. Okay. Let's reduce the range to to 5. And you can also have nested a lot of statements within one block. So let's write an if block within this statement. So if I is greater than 3, okay, again we have another block, print number found is greater than 3. Okay, so you can see that now we have a level of indentation. The first occurs over here for printing I till for the main for loop. Again, inside the for loop, we again define an indented block. So here we have a next level of indentation which occurs over here. So, and here you can see there are 4 spaces. Here there were 2 spaces. So as the spaces go on increasing, you can understand that the levels of indentation are being arranged accordingly. This happens automatically in Python, and you don't need to specify it on your own. But if you are using some other coding platforms, or if you are using a simple notepad for writing Python scripts, so in that you have to take care of indentation a lot more. But over here, when you have an IDE, or if you have any Visual Studio Code, so softwares like that, then you have everything being done automatically. So you don't need to worry about it. So let's execute this code. So first from 0 to 5 and from I plus 2. So another print statement got executed. And again, we see the if block also got executed. Okay, so I won't go into detail right now what all these constructs mean. We will study everything step by step. So just so you know that this is how the indentation works. when we have multiple nested blocks. Okay. Next, we have comments in Python. So we just saw about all that. Suppose that you want to write, so you want to make modifications in your code, and over there you can simply comment out those lines of code that you don't want to execute. So I wrote print hello. I also want to print cheers. So I want to omit the hello part. I only want to print cheers. So I can just comment it out. Okay. And in Python, we don't have any specific multi-line comment. We only have this hash as your to write your all your comments. So you can use hash to on multiple lines to write your multi-line comments. So this so you have one example over here. This is how you write a comment on multiple lines. So that can be done. Another thing that you can do, this is called as a doc string. So it gives us a you can use it within your functions when you write your functions. And these doc strings are very useful if you want to know the specific functionality of routine that you have written. So instead of writing a comment on multiple lines, you can also make use of doc strings as well. So these are also a form of comment in Python. Okay, so let's begin our session 2. Is my slide visible?
Yes, ma'am.
Okay, sir. We begin this session by going through some of the very fundamental concepts in programming. Variables. So variables are the named memory locations, and you store values in a program in these variables. So when you write A is equal to 10, B is equal to A plus 10, it means that there is a memory location called which has been named as A within your program, and you are storing the value of 10 within that location. And you can also have another memory location that you have. We execute both the statements. So after computing, 10 plus 10 is equals to 20, and that gets stored in this memory location, which is referenced by B, the variable B. Okay. Sorry, sir, can I just reshare this? It is not getting to full screen.
Which one? You can reset that one. Nah? You are the
Yes.
host, I think.
Yes, sir. Okay, got it. So this is how your variables are organized within a program. You'll have lots of variables that you'll use to store different values in a program. Here we are storing integer. This is called as an integer, a numeric value, which we are storing in the variable A and B. So next, some of the naming conventions, like in all other programming languages, we can have some naming conventions that we need to follow when we are naming a variable. The first thing is that for your program to be readable and easily understandable, your variable name should be descriptive. So over here, when I use A is equal to 10 and B equals A plus 10, it is not really descriptive. Had I used num1 and num2 or summation of something like a descriptive name for the variable, num1 and num2, it would have been a lot more better to understand. We will understand by the name of the variable that we are using storing numeric values. So that's where your naming conventions comes into play. So when you are coding like some application, then make sure that you have your variables named correctly as per their applicability. So over here, when we are using simple scripts, when we are writing simple code just to understand the programming concepts, then we may not need to go into so much of depth. But when you working on some application or some development team, then obviously you have to take care of these small things. Next, we start this variable name with a letter or an underscore. We cannot use numbers at the beginning of a variable name. So this is, I think, common to a lot of other programming languages. So say the same conventions are also used over here. Variable names are case sensitive. It can contain only letters, digits, and underscores. So it is alphanumeric, and the only character that we can have, it is the underscore. Note that the variable name cannot be the same as a keyword in Python. So keywords are some of the reserved words, and you cannot use those keywords as your variable name. Even in Python, there is the word sum is also a keyword. You cannot use sum as your variable name. When we code in other languages, it is very easy to use. And when I was learning Python, and when I was learning as a beginner, this was the first error that I encountered. I was using sum is equal to num1 plus num2, and it immediately gave me an error that it is a reserved word. And then I studied it, that it is a function, it is a reserved keyword which is available in Python. So take care about that. Best is that you come up with your own descriptive names for your variables. Also, the variable name is not going to change throughout the code. Maybe the value which is contained within that variable, that can change. So in the previous example, when we have a is equal to 10, had I written a is equals to a plus 10, then the value of a would be incremented by 220. So that is, the change is occurring within the value of a, but a is not undergoing the name of the a. The variable name is remaining constant throughout your program. So Python is having a set of keywords which are reserved, and you cannot use these keywords as variable names or as function names or any other identifiers in your program. Some of the keywords in Python programming language are mentioned over here. So some of these keywords you will also come across, such as import is a keyword which is used to load the different libraries in Python. Then right now you came across one keyword which is print, I think. Yeah. So we have if and else is there, for is there, def is there. So these all are several keywords in Python. And as you start working, as you start writing or building your own scripts in Python, you'll get more familiar with all whatever those keywords are. Next, we have the assignment operator. So this is used to assign values to a variable. Is equal to that you have, that you are writing, num is equals to 27. So this is your assignment operator. It is assigning a value to the variable num. So right now num is containing 27. So we can also have different kinds of assignments within Python. So num plus equals 2. So it is equivalent to writing num is equals to num plus 2. So you can understand this is like a shorthand operator that you can use. And this is very this comes very handy when you are writing your code. So if you want like a loop variable that you have and you want to increment it, then you can use these statements. Then we have num minus equals 10, which essentially means num equals num minus 10. So like that, we have different kinds of assignment operator which involves different operators in Python. Okay, so before moving on, we are first going to look into the mathematical operations that are available in Python. Okay. So have your Google Colab notebooks ready? We'll have some, yeah. So here, like we have 1 plus 2, execute it, you have 3. Similarly, 2 multiplied by 6, we have 12. So suppose you can also work with negative numbers. And this is a recurring decimal number. So it's like 0.333 till infinity, but in Python, there is a range of numbers that it can store in a particular data type. So as per that, we have this one occurring. And there is also a different kind of division in Python, which is called as integer division. So if we write 5//2, then it is dividing 5 by 2, which gives 2.5, but it is removing the decimal part. It is only keeping your integral part. So here we have just 2. Again, we have 5 modulus 2, which is a remainder operation. So we are trying to compute what is the remainder when 5 gets divided by 2. So here we have 1. Another operations that is kind of exclusive to Python as an operator. So you don't have this operation in other programming languages. We have the power function available in a lot of other languages, but this is specifically an exclusive operator available in Python. If you write 2 double star, that is the one which you use for multiplication, double star 10, then it raises 2 to the power of 10. So my output will be 1024. So people here, please try to execute these mathematical operations in your Colab notebook. And when
just do the hands-on simultaneously so that it will be more easier to understand. All of you just open Google Colab and do the assignment parallelly with the map.
okay, it's working. Anyone not working? Is there anyone who's not able to understand something?
Ma'am, could you explain the to the power of?
Yes. So this is an operator in Python. Just like you have plus, you have minus. So double star becomes an operator in Python. So when we are writing 2 to the, this is 2 raised to the power of 10. When you want something raised to the power of something, then you are using this operator. So don't think that it's some function or anything. It's essentially an operator. When you are writing it like 2 into 10, it's giving you 20. And when you are using the operator double star, then you get 2 raised to the power of 10. You can experiment with other kind of expressions as well. 2 raised to the power of 2 will get 4. Let's try with 10 raised to the power of 2, 100. Is that clear?
Yes, ma'am. Thank you.
Okay. So anyone, any explanation required for this mathematical operations? So if you are able to understand, this is your short in-class assignments also we'll have, and I'll give you like a quick 1 minute and you have to come up with the solution. So based on whatever operations that we learned right now, whatever mathematical operators that we know, can you come up with an expression like how should we calculate this one? So come up with a mathematical expression to calculate the value of this expression. If anyone is able to do it, you can just write in your chat box. Yeah. Yes, Harsh, it's correct. Did you execute it? Okay. Okay, fine. Yeah. Others? Okay, Kuldeep, I got your answer. It's correct. Hmm. Send the link. Which link? Collab? Okay. Just all of you save this link. Okay. Sorry. Uh, so when you are writing this expression, yes, sir. So they are losing the link for Collab.
Yes, yes. Okay.
Yes. Sir. All of you, please bookmark this link in your browsers so that you'll have it available. Yeah. So when you are writing this expression, the first thing that we want to do is the inner expression. So it should be from the innermost expression should get evaluated first, followed by we have 3. Then we have a division. So we'll go there /4 to give our division, and this entire expression that we have to raise it to the power of 5. And this is the answer that we get. So cross check with whatever expression that you have written. And this is how you have to code and code this particular expression in Python. Okay. Okay, done that. Okay. So I hope that these basic mathematical operations are clear to everyone. And in Python, you can even, if you have if you work in that area, then you can use Python to compute such complex mathematical calculations as well. So it is possible to compute very large calculations in your Python programming language. Okay. Someone has an error. Okay. Can you paste your error message? Just share your error message so that I can help you out. So next, we also see some more examples over here for mathematical operations. So we are storing A equals 3, B equals 2. In Python, we have the option to print your print consecutive values only using a comma separation. So there will be no error, don't worry. We separate all the values within your print function using this comma operator. So if you want all the answers, we have 3 plus 2 5, 3 minus 2 1, 3 multiplied by 2 is 6, and 3 divided by 2 is 1.5. So suppose you wanted to have integer division, you don't want this decimal point right now. So just use double slash, and then we have 5161. So this is the integer based division. To Bibhu Datta, if you have an error, can you just tell us what the error message is? You don't need to share your screen. It's completely fine. You just tell us that what is the error prompt that you are getting? What is being written over there? Like in the previous example, I showed that when an error occurs, it will give you something like indentation error. Something is written over there, the main part. So just let me know that what is the error message that is coming. Or if not possible, then we can deal with it in the evening session.
Yes, in evening session we can.
Okay. So these are some of the examples. So again, with
Ma'am,
multiple
I share it in the WhatsApp group. Please, ma'am, check.
WhatsApp group,
Actually, ma'am is not there in the WhatsApp group.
not there. Yeah.
So we can- in evening we can discuss, fine. Or you can write down the error message here in the chat box. Let
Yeah,
me
just
add, ma'am.
uh,
Okay. Let me add. Just a- Okay, you can share it again in the WhatsApp group so that ma'am can see. And
yes, sir. Your braces are not properly placed. It's a syntax based error, and you've not used the operator that we told. So for to raise something to the power of a number, you use double star as the operator. So just fix that error. Your syntax is not proper over here. So this is what I was talking about. When we start learning Python, it is very common that you may have syntactic errors. So just check all your braces and also check the operators that you are using. I'll just copy paste this expression. Try this. Okay. Okay, that will resolve your issue.
Yes, ma'am, done.
Done. Okay. Okay, so we move on to the next part. We also have a lots of mathematical expressions over here. So again, with repetition, with repeating different kinds of expressions and experimenting with them, you'll get familiar with them and also learn a lot more. So here, like I have added a lot of small scripts are there. So whatever I thought that would be useful to you. Another thing that you need to remember, in other programming languages, we have this unary increment and decrement, like x plus plus, x minus minus, or plus plus x plus minus minus x. So these things are available in other programming languages, but in Python, we don't have these. Python does not support these unary operators. So instead, we use this shorthand operator plus 1. Then we have x star equals to, then it is equivalent to writing x equal to x multiplied by 2. Okay. So you can see for yourself that this will work. Okay. So here we had also remember what we initialized x to. So x was initially x equals to 10. And the value of x did not change even if we have performed a lot of computations on x, because we were not changing the value of this stored in the variable. So if we had written something like x equals to x plus 1 or used the shorthand operator, only then the value will change. So if you want to simply experiment with different mathematical operations, prefer to use these print statements or simply play with the interpreter of the code cells in your Colab notebook, rather than changing the value of the variable again and again. So here we have the original value of x was 10. Here we have it is 12. We have it is 11, and we have x equals x multiplied by 2. So value of x changed. It is now 11. So 11 multiplied by 2 is just giving us 22. Now, another thing that in Python, we can check the type of a data. So some data. So here we have stored 2.5 into the variable y. So Python supports int and float. Float for floating point is decimal numbers. So here we have an application of the same. We'll read more on data types, but this is just a demonstration like how it works. So we have float in Python. Y 2.5 is your floating point type, and we want to perform some mathematical operations on that. So here we are first printing y, then y plus 1, which is 2.5 plus 1 gives us 3.5. Then y multiplied by 2, which is 2.5 multiplied by 2, giving us 5.0. Then we are raising y to the power of 2, which is 2.5 multiplied by 2.5. So that is what we mean to the power of 2, like squaring the number. Then we get 6.25. So just try these code snippets in your Colab notebooks. Let me know if there is any issue. So we'll just code it along. I'll just explain, and along with that, you side by side try to run these code snippets on your own. Okay. All right. So let's move on to some other concepts over here. We can also change the value of a variable. So this is the code that I executed on my local Python installation. I'll also show you that in our evening session. We will talk all about the local installation. But for now, try to execute this code in your own Colab notebooks, in your own code cells. So first we set the value of the variable is equals to 27. So initially it was an integer variable. And next we change the type, completely change the type. It is no longer numeric, it becomes a string. It is containing some text data which says good morning. And in the same variable var, and we print it out, and it prints up the string which was stored in it, good morning. And we when you can see one thing, when you print a string, like if you just type in the string in your interpreter, it comes like in quotes. But if you are printing it, it will come more like how it should get displayed to the user. So this is one difference in how print statement modifies the way your text appears on the screen, not like a string, but like something that needs to be displayed. So try out this part as well. And this is an important concept, that in Python, you have the freedom to change the value of a variable even across the types. So like in other programming languages, if you had defined this variable var to be an int, It will always and always store integer types only. You cannot have this much freedom in other programming languages. You have to separately define another variable to store the string good morning. But in Python, you have this flexibility that you can change the types. Like, you don't have to worry about it. A variable is simply a location in memory to store some data. You don't need to worry what data you are storing. So try it out and let me know if there's any doubt. I hope most of you are coding along. Even if you have joined through a mobile phone, you can still go to Google Colab on your Google Chrome browsers or any browser that you have. From your phone only, you can access the Colab notebooks. So that is an exciting feature that you don't need to worry about going on to your desktop, but it is always advisable that you work on these small snippets, whatever we are teaching. It is advisable that you join from your desktop, or at least the coding part that you do. You watch the instructional video, you can watch on your mobile phones, but the coding part, try to do it on your desktop. Because it will give you a good experience. So this is how we change the value of a variable. And another thing that Python supports, it is multiple assignments. So you can assign the values to multiple variables at the same time. So try it out as well. Just now, type in any three variables, name any three variables X, Y, Z in a row. Just, it is all comma separated, and 10, 20, and 30. So all these variables in the sequence that you define, in that sequence, the values will be stored. So now X will contain 10, Y will contain 20, Z will contain 30. So these features are not available in your primitive programming languages like C or C++. A lot of restrictions are there. But as you can now, you must begin to understand that we have quite a lot of freedom when we are working in Python. Okay. So try this multiple assignment. It's an important concept. It assigns all the values at one go in whatever way you have defined. So if you change the arrangement, the values will also change. So instead of X, Y, Z, if you had Y, X, Z, then Y would have 10, X will have 20. So try this output, this code snippet. And whenever you are working on your Colab, try to maintain your notebooks. So if for this day one, all the sessions, so in one single notebook, whatever code snippets that we are discussing in this session, try to store it. So that if later on, if you want to refer to some particular coding construct, you can do that by coming back to that notebook. Okay. Anyone, any doubt till now, whatever concepts that we have discussed?
I think no doubt.
Okay. No doubt. Okay. Okay, so let's move on then to the next sessions, next part of this code. So next we shall introduce data types. So already you have encountered so many data types in Python. The main, there are only 4 main data types in Python. So the integer, int, then we have float, then string, and then Boolean. So now you already know integer values like numbers, positive, negative, 0, all the numbers on the integer number line. So those are getting stored in your integer value. If you want to have a real number value on the real number line, whatever values that you have with a decimal point, so those come in under the category of floating point data. So we call that float data type. Next, we have string data type, which is text character that we specify between double quotes, like single quote or double quote that you can have, like x equals to hello. So hello is a string. Even a number, if you can put a number inside those quotation quotes, then again that number becomes a string. So anything, any data that you place between those two quotes, that becomes your string. And we already worked our first program, the hello world program that we wrote in Python. That was your first introduction to a string data type. So and finally we have the Boolean logical values are there, so which signifies only true and false. So a Boolean data type will always have only two values, which is either true or false. In previous programming languages, if you have attended courses on C++, you may have also seen that they use values like 0 and 1 to indicate true and false. So if they mention true or if they mention 1, then it is like equivalent, I think. And in Python, you cannot use zeros and ones interchangeably. So here you can have only true and false. You cannot write x is 0, which becomes true, and y 1, which becomes false. No, you cannot do that. So over here, we have specific values, and also notice that the T and F, these are in capital letters. So that also is an important part of your Python syntax. So remember that. So every data value in Python has a type. So whatever data values that you have worked on till now, whatever code snippets that we worked on together, everything has a type. So you can check it whenever you assign something to a variable like x equals to 10. You can use the type function to check the type of x. So when you write type x, it gives you the data type of that particular variable. So these are the 4 major data types in Python. Next, we come to a very important concept, which is called as typecasting. So in typecasting, we are actually specifying what type we want our variable to be. So when we have 1, it is already 1. But if we want to explicitly specify that int 1, then here x will be 1. Suppose we have a floating point number like 2.8. And we also want that to convert it into an integer. So we can write int 2.8 and then the value of y will be 2. Then the third example that we have over here, if we write z equals int quotes 3. So here when you are writing 3 within the quotes, it becomes a string data. Now we are converting that string into an integer type. So now z will be 3 and the string got converted into an integer. So this is how we work with typecasting. We can change a variable belonging to one data type to another data type. So that is possible, and we can do it using these functions. So we are explicitly defining what type we want for our variables. So try it out in your Colab notebooks. Write these 3 statements and see, try to print also, try to print the values and try to check the type as well, whether it is working or not. You may want to confirm, right? So when you write z equals int and quotes 3, also type, check the type of z. So write print type z and just check it that if it is working or not. I'll also code along with you. So let me go back to my Colab notebook. Okay. So here we will write z equals int 3. And now we will check type of z, integer. So now you can understand that we are able to cast one data type into another. So here the string got converted into integer. Okay, so some more concepts in typecasting are there, which we'll discuss right now. So there are two types of typecasting. One is implicit and one is the explicit. So implicit is happening automatically. We don't need to forcibly convert something. So there are certain instances when Python is automatically converting one data type to another data type. It usually happens during mathematical executions, such as if you want to add an integer to a floating. So suppose we want to add 1 to 1 plus 2.5. So whatever output that we get, it will be 3.5. So it is getting promoted. So we don't have the result as an integer, but it gets promoted to a float. So this thing that occurs, we are not explicitly saying that we want the output as float, but Python does it automatically. So let's see the implicit type conversion first. So comment your code when you are writing some important concepts. So here we have implicit type conversion. And next we will define. So my first number will be an int. So I define it as the name of my variable is a, and I want to specify that it is an integer variable. So I keep it as, suppose I keep it as 20. And I have another variable, which is float. And I keep it as, let's keep it at 0.5. Okay. And now I have a result variable where I am trying to compute the sum, a int plus b float. Print the result. So we get 20.5. And if you want to check the type of result, that is float. So now you see that this automatic conversion is taking place. And the one which is having a higher like range, and the one which is given more importance over here is the float, because when we are computing this operation, it comes as 20.5. So if we were storing it in an integer, we would lose some information. So Python does all of it automatically. It has all these features within the programming environment. We do not want to lose any data, any information. So even the decimal point can count as a very important feature if we are working with scientific computations. So an automatic promotion of types is occurring. Here integer is getting converted to float, then getting added and stored within the result. So you don't need to explicitly say that we want it to be float and then getting added to it. So this is happening within the Python environment. Okay, so this is your implicit typecasting. I'll move on to explicit typecasting. I hope you are executing it side by side. We can also check the type result, the type of integer, and the type of the float that we discussed right now. And this is a very good way to skip print statement. So if you don't want any print statement, you can simply type it out on this interactive code cell. You'll get your outputs. So first we have float, then the value of 20, which is an integer, and the value of 0.5, which is a floating point. Okay. Okay, so we discussed a lot of data types. So we saw numeric types and how the computations are taking place in integers and in floats. So let's try one thing. Is it possible that to add an integer and a string? Can you do that? So let's try it out. Suppose we have a number which is, let me say 1, 2, 3, 4, 5. This is our number. And we have a string. So let's keep our string as str underscore num. And we also have this string. This is also 1, 2, 3, 4, 5. Let's try num plus str num. See, so here we get an error, and it is a type error, which says that unsupported operand types for plus, int and str. So this actually means that this plus operation is not supported when we are working with int and string together, because an implicit conversion is not occurring under this condition. If we are expecting the Python interpreter to automatically convert the string to a numeric type and perform this computation, or convert this num to a string and maybe concatenate it into another string, so that is not occurring by default. So over here, like, you have the implicit type conversion that occurs when you are using your float and your integers, but the same thing is not happening when we are using strings and numbers. So it is one of the reasons, because it is not supported within Python. And there, just like in all other programming languages, there are certain rules and regulations, like what operations you can do, what are legal, and what all operations are supported in your environment. So over here, we understand that, okay, implicit conversion is not allowed in this case. So implicit conversion not possible. So what can we do to resolve this? We want to compute the sum. So here we can use explicit type conversion. So here we can do num plus, then convert the string to an integer using int. Then again, we can write str underscore num. There we go. There we get the output. Okay. So this is a basic summation that we are trying to compute. 1, 2, 3, 4, 5 plus another 1, 2, 3, 4, 5, which is stored within a string. So the string gets converted to an integer, and then we get the final output. So this is supported because now we have converted the string into an integer. So this plus operation is now getting supported because we have the operands belonging to the same type. The next thing that we can try is, you can convert your num into a string and str num. So, okay. So this is something which is called as concatenation. So what happens is, in strings, we don't have any summation or we don't have any addition being taking place. But when we have string data, so if you have text, so suppose if we have some text like text A saying hello and text underscore B saying world. And now we want to print them together. So then we can use this operation, which is the concatenation. So now we have hello world. So if you want to customize, if you want to add some space, you can do that and you can print it out again. Now it is morning, so hello world. When you start experimenting with different operations, then you also discover new concepts, just like we were actually studying about typecasting, but it also revealed the underlying operation of concatenation which occurs within the strings. So similarly, you can try whenever you think of something, whether it is working or not, just try it out. Just go to your Colab notebook, just type it out and try running it. If you have any error, try resolving it, experiment with your code, and if if some doubt persists, we are here to help you out. Okay, so this is about your typecasting. Explicit type conversion is something that it is like a forced conversion. So we are converting the data type of an object to a required data type. And these functions that we just saw right now, int, float, str, so these are being used to perform the explicit type conversion. It is also called as a typecasting, where the user casts the changes or changes the data type of the objects. So right now, the example that we discussed, that is your explicit type conversion. Up next, we are going to learn how to get user inputs from your console as well. You can take, or right now we are going to work on Colab, and we'll see how the user inputs are, how to take these easy user inputs. So up till now, whatever we have discussed, is there any query, anything that you want some more explanation on, or any concept that you need more explanation? Okay, you can type in your chat box. Also, I hope that you have been trying all
Yes, yes.
these code snippets.
Yes. Anyone having any doubt, just ask here. Or you want to know more about any particular statement? Okay, continue.
So someone just asked one
Okay,
question.
fine.
Yes, sir.
Yes.
Implicit and explicit, okay, difference. So the difference is mainly in the fact that here your implicit type conversion is occurring. We are defining a int, that is a variable. So let me just make it simple. Let's have two variables, a and b. So a is your integer type, b is your floating point type. When you are trying to perform addition, like you try to perform addition right now on a number and a string, so that gave an error, right? But over here we are not getting any error. Here also there are different types. Here it is 20, which is an integer. Here it is 0.5, which is a floating point type. But when we are trying to execute it, it gives us the output perfectly. So what is happening behind the scenes? So we have the implicit type conversion. So what the compiler does is that we have a, so it will convert a to a floating point and it will add it to b. So this means that it will become something like 20.0 plus 0.5, which gives us 20.5. In every programming language, whatever operations that we have, when you have two operands, then or any number of operands that you have, it is always going to work on similar kind of data, similar data types. So for the plus operation to take place, we have to have A and B belonging to the same data type. Otherwise, we will get an error, just like we got an error when we tried to add an integer to a string. So that is not happening by default by the compiler. But here, this is supported by the compiler, this implicit type conversion. It is there, it is available in Python environment. So we don't need to write this statement, float of A plus B. We don't need to write it. We don't need to force the compiler because it is already doing it. So this is what is called as implicit type conversion, the type conversion which is happening automatically. So you cannot see it in action. You only can understand what is happening when the execution process takes place. So this is the explanation for that. That is something that you cannot find, you cannot see it, but it is how the working is going on, underlying working is going on. And the explicit is where if we write it like float of A plus B, that becomes explicit. But this is not necessary. Over here, it is necessary. Over here, if we want to add a number to a string, then we have to convert that string to an integer, or we have to convert that integer to a string to perform the operation. Same operands should be the same type, data type should be there. Then only your operator will work. So I hope this is clear. Next to implicit type conversion. Swapna, I did not understand which part are you asking?
This one, ma'am, just to next where your cursor was there,
This one, float of A.
just below that, ma'am.
This one.
No,
Oh,
ma'am,
where
down.
1, 2, 3, 4,
In-
5, that example.
Yes, ma'am. Yes, ma'am. This one.
Okay. So here your num, it is an integer. Okay. We saw that we have four data types. We have integer, we have float, we have string, and we have Boolean. So Boolean we are not working with currently, but here we are trying we are working with integer. Then we have your string. Over here, implicit conversion is not possible. When we say that, it means that it is not supported by the interpreter. Automatically it is not happening. It is supported in Python, but you have to do it on your own. Your compiler does not know what you want, whether you want the number to be converted to a string, or whether you want the string to get converted into an integer. So it cannot decide on its own. So which is why such operations are not given automatically. It is user dependent. So how you want to execute. So I gave you two options. So two options is, first, either you can write num plus int strnum, which means that you are performing simple addition, or you can perform concatenation where you can write strnum plus strnum. So what happens is that when we have strings, this is how the addition takes place with strings, and this operation is called as concatenation. So when some implicit conversions are supported, some happen automatically. Mainly this float and int one, this happens automatically. So this type promotion we say when an integer is promoted to a floating point. And over here, we have to do it on our own. So this is your explicit type conversion. Is it clear now? If you need a further explanation, we can discuss it in our Q&A session today evening. Okay, I'll again I'll note it down. I'll discuss this part once again. So for people who are still having some doubt regarding this, we'll have a discussion on it. Okay, please remind me during the session what all topics you want some more explanation on. So okay, next we move on to getting user inputs. So when you are working with programs, you want your programs to be interactive. We cannot have a scripts just like that. Some data needs to come, and we have to continue processing it. This data can come from files. This data can come from databases. This data can come from your online resources like online websites. You can have your data from Excel sheets. Your data can come from Word documents. So a lot of sources of data are always there. And when we are working in Python, and specifically when we are working with data analysis or data science, we have to always process various data in the form of text or images or audio or video. So lots of applications can be done in Python, but the first thing that you can do is get user inputs from your console. That is your first stepping stone into getting data from some source and working with that data. So before we actually think of importing data from external sources, so just let's try that. How do we work with data? How do we take input from the user? So over here, this is a small code snippet which I request you all to try. We are taking input, like my name is a variable which is taking the input, asking for input over here. Enter your name. So this is a prompt. It will come on your screen when you execute this code. Enter your name, and then you print your name. So when we print, whatever the user has input after that prompt, it gets stored in my name variable, and then we are printing it out. So when we print it out, we see that okay, the user gave some data as the input, it got stored in my name, and then it got printed out. So it does contain that data. And you can also check the type of this variable, my name. When we check the type, it comes as string type str. We can also experiment more. Okay, so first just get this user input. So here I have enter your name. So it will come something like this. And here you have to type it out. Enter your name. And when I print my name, I get it out as the output. Similarly, we have the checking the type of the data that just got stored, that the user just entered right now. Are you all able to do this? Please try this out. It is a very important concept, how you have to take inputs from the user, because a lot of our work will be around this part only. So you need to have your programs interactive. You cannot just hard code everything. So a lot of concepts will be based on and around how the user interacts with your program. Okay. So you have 3 people till now who have done. Others, please try it out. It's a very important concept. So these functions that you have, this input and print, these are very widely used for the input and output operations in Python. Most of your programs will contain this, these functions. Okay, so I think a lot of you have already done this. So the next input that we are going to take, it will be a numeric input. And so let's see how you're going to do that. So suppose we have this command which says that we want our age, but we know that when we have the input command, it accepts the data in the form of a string. But we cannot have our, but we don't want our age to be a string. We want it to be a numeric value. Suppose you want it to be a numeric value. So we have to typecast it. So here we have the typecasting concepts coming into the forefront. So here you have to define, like you have to use int, then you have to take the input, and thereafter you get the type as the desired data type that you want your input to be. So you can also have any other data type if you want, like int and float you can have over here. So let's try it out in Google Colab. So we have int my age, enter your age. So my age is a variable which will store my age as an integer. And when we print it out, we get it like 25. So let's check the type, and it's an int. So here we have the explicit typecasting, explicit type conversion is there. So you can notice it mostly occurs when we are working with a non-numeric as and numeric. So if we want from string to an integer, then we are using, we have to use the explicit type conversion. It's not going to happen automatically. You have to tell the compiler that this is the data type in which I want my data input. So when you specify, then you have it like that. Okay, so let's have another thing. The same code, but here we are taking it as float. And so age cannot necessarily be in float, but if you want like year and month, if we want something like that, so we can write our age as a decimal number. So let's try that as well. So write age as, I'll write age as 25.5 and we'll print it out. So there we go. And if we want our type, then my age over here, that will be float. So I hope you are able to understand how the explicit type conversion works. Concepts will become more clear as you are going to write code. A lot more scripts will be there. We will give you some questions as well in every session, and we'll also solve them together. We'll not leave you to solve it. We will solve it together. So it's not like an exam. So we are, as and when we write more and more code, we are able to understand the concepts better. So since most of it is new, it can seem like something out of the box or something extremely new or fresh. But as you start working on your scripts, you will be able to understand it better. So have you taken user input, like your name and your age?
Yes, ma'am.
Okay. Others?
Yes, ma'am.
Yes, ma'am.
Anyone having any issue, you can ping over here in the chat box. Okay, so okay, most of you are done, I think. Okay, till now, I hope everything is clear. Like if any doubt is there, anything that still needs some more explanation, then let me know. Apart from the typecasting, if there's anything else that that's there that you want to know more about? Okay. So next we are moving on to the conditional statements. So just in the last session, I think in the beginning of this session, I just displayed one code snippet, which was in for loop and coupled with an if statement. So now we are going to understand what all those things mean. If you did not understand back then, no issue. We are going to dive into those concepts right now. So conditional statements are used for decision making. So like we have some conditions and we want to evaluate it, like in answers like yes or no, like true and false. So that's where your Boolean values come. Your Boolean values will work out. So here, if you want to execute a code, only if a certain condition is satisfied. So when we are writing if some statement, that is your test expression, and we want to check whether that expression is satisfied or not. And if and only if that expression evaluates to true, then only the statements written below it will be executed. And in Python, we have this if, else, else statement. So if you have worked in other programming languages, we used to have earlier if, else if. So that else if has been condensed into elif. So that is the same concept, but the keyword used is different in Python. And else. And this is used for decision making. So I'll give you the demonstration you need to understand for the conditional statements. So yeah, so let's move on to your Colab. So it looks something like if, and we have your test expression over here. You don't need to write it anywhere, just see. And we have the indented code, and then we have statements. I think, okay. So it's written in your markdown, so I'm not able to get the indentation over here, so don't worry about it. So it's essentially that we have a test expression, and if it evaluates to true, we have the statements underneath and they are going to be executed. So let's try a small code snippet in this one. So let's check whether a number is even or odd. When is a number even? When it is divisible by 2. And when is it odd? When it is not divisible by 2. So a simple construct we can write. We can take a number as an input from the user. So this is where your interactive ability of Python is very much useful. So enter a number. We take the user input, and we can since this user input is as a string, so we have to convert it into an integer to perform mathematical computations and comparisons on it. Now, if this number that I have, how do you check if a number is divisible? So we check using a modulus operator. A modulus operator gives us the remainder. So when I am writing num mod 2, I am getting the remainder after dividing number num with 2. What is the remainder? What is left out? So if there is no remainder, I conclude that this is an even number. So if the remainder is 0, then I say print number is even, and else number is odd. Just execute it. Enter a number. So let's try with 5. Enter. Number is odd. So again, we can check. another number like 10, number is even. So what is it doing? First, it goes to the if this construct, if block, and it is checking this condition. And when this condition is satisfied, it will execute the statements written below it. So in its block. So if block will get executed, print number is even. And if it is not getting satisfied, if this condition evaluates to false, then what will it do? It will go to the else part. In the else part, it will print number is odd. So first, as we have over here 10, so first 10 goes over here and 10 mod 2 evaluates to 0. You can check it over here as well. If you do 10 mod 2, it will evaluate to 0 because there is no remainder left. So that is when it is number is even. And now, if we want to check another number like 3, number is odd. And you can check 3 mod 2. It is 1. Means it is not equal to 0. Anything which is not equal to 0. Then we are saying that it is an odd number. Only and only when the remainder is 0, then it is qualifying as an even number. So this is how your conditional statements work in Python. Please try it out, this particular code snippet. And let me know if anyone is encountering any issues. Let me know in the chat box. Where are others? More people, please. Yeah. Okay. So I think you're now able to understand the if statement. Okay. Coming back to today's agenda, we covered variables, data types, user inputs, and conditional statements, which is if else. I'll also show you how we will write the elif code in the code. I'll also cover the multiple conditions. And the last part which is remaining is designing a calculator in Python. So let's code it together. All of you focus on the Google Colab notebook. We will write a very simple calculator over here. All the concepts that you have learned till now will help you to write this program. So when we have a calculator, we first, what do we do? What does if you have a calculator with you, what you will do? You will punch in the numbers, right? So you will punch in the numbers, that will be your input. So similarly, we also have to take user inputs over here. Those will be the operands on which the operation, the mathematical expression will be based on. So let's have two numbers. So let's take num1 and num2. And we have to take the input. So this is how I reuse the code. I don't like writing it again and again. So I just copy it down. Okay. So we have two numbers. So enter the first number and enter the second number. Okay. So now we will run this and we will store our inputs. So first number, I'll take it as 10. My second number, I'll take it as 5. Let's keep it simple. And now we will perform the operations. So in a calculator, you have multiple operations. So what else do you input? Apart from your operands that you have, what else do you need? You need to also tell the calculator what is the function that you are going to use. Either it is plus, minus, divide, multiply, modulus, anything. What is the operation that you want to use? So over here, we also need to take as an input the operator. And the operator, we will take it as your string. So enter the operation that you want to perform on these numbers. So we'll also take this as an input. So suppose I want to perform an addition operation. So I'm entering over here plus. Done. The next part is where your decision-making constructs will be used. We are going to check what operation is there, but we also want to have multiple, we want to have flexibility. We don't want to hard code anything. So our calculator should facilitate at least the basic operations. So first we will check if our operator is equal to plus, it will print out. So let's keep it a little bit more descriptive. I keep result. Result is num1 plus num2 and print result. Now, this is your if block. We will have multiple conditions over here. So we are taking plus, minus, multiply, and divide. We are taking 4 operators over here. So the next part, we will have the elif construct, which is equivalent to else if. If I translate it into Hindi, I will say ye nahi to ye condition. So here we are having multiple conditions. Ye execute hua, then we have this output. Nahi to ye execute hoga. Nahi to, agar if that is not getting satisfied, nahi to we good. So when you translate your code into like a mother tongue or the language that we use in a day-to-day life, it also becomes a lot easier to understand. So that's why I had to add something over here. So we have elif, else if operator that we have equals to minus. What are we going to do? We are computing the subtraction of these two and printing. Or one thing we can also do is that rather than having the print, okay, leave it. We'll have it. We will code in a more efficient manner from the next session onwards. I'll also tell you what are the efficient practices of coding in Python. We have result num1 multiplied by num2 and else. So this is a final operation. If nothing is valid over there, we are going to execute this one. So this is a default case, something like that. So I'm keeping it to be a division operation. Print result. So within an if block, you can have multiple statements. So let's try this out. What did we get? 15. Okay. So our first number was 10. Second number was 5. Our operator was plus. So it satisfied the first condition. So let's change our operator. Let's change it to minus. Fine. Now again execute this statement. So 10 minus 5 is 5. So the next condition, elif operator, this one got executed over here. Let's again change the operator. Let's change it to multiplication. Now again execute this code. 50. So 10 into 5, 50. So this is the third condition which is getting executed. And now next, the last operation, if there is nothing, then we are only thinking that we have 4 operations over here. Here is 2.0, num1 divided by num2. We can also use integer division as well. You can you customize your calculator function accordingly. So this is 4 basic operations, but our code is not optimized. It is not optimal in the sense that if I use any other operation over here, if I'm not aware of what operators are available to me, in case I enter a modulus. Okay. So, and again, I execute it. Yeah, so this is how this is the problem, that even if we have some other operator which is not division, it will again execute the division operation because it is written as the else case. In else case, we don't have the condition. अगर ये satisfy हुआ तो ठीक, नहीं तो अगर ये condition meet कर रहा है, then execute this. नहीं तो अगर ये condition evaluates to true, then we will execute this. अगर इसमें से कुछ भी नहीं है, then it goes to the else part. So here what is happening? It is none of the above. It is neither plus, it is neither minus, it is neither multiplication. So that is why it is going to the else part. When you write other so it is because of the limited options that we have given in our calculator function. When we will design a function, when we will define in for the calculator, then you will see we will have all the different kinds of operations in that. We won't miss out anything, but this is just for the sake of understanding that how things are getting executed. So to keep it simple, we have taken the division operation in the else case. So I hope that this part is clear to all. So this is your first if block. Continued to that is the elif. Then again one more elif, and last we have the else part. Don't worry, I will share this notebook with you all so that you can go through all the code snippets that were discussed today and you can work it out.
I think
and
Devolena will share the video also in YouTube.
Sure.
Will upload the video so they can also refer that one.
yes, sir.
No issue. So I think Devolena we should stop here. Now time is 1:25.
Yes.
So I think we'll stop here. And
Sir,
tomorrow.
I'll just drop the link for this notebook so that they can
Yes, you can.
access this.
In the WhatsApp group, you can put it so that it will be better.
Okay, sir, I'll do that.
Excuse me, sir.
Yes. Yes. Yes, anyone having any query?
Yeah, sir, I have an issue. I mean, I didn't join the WhatsApp group. So can you add me?
Okay, I will add. Fine.
Okay.
You just check your mail. The link is there. You can add from there. Okay. Check your mail.
Okay, sir.
Okay.
Yeah.
Okay, sir.
Okay, I think Devolena, we should stop here. If possible, all of you can just on your video for 5 to 10 seconds so that we can take one snap.
Yes, sir.
All the students, all the participants who can, not compulsory. Right? Am I audible to all?
Yes, sir.
Just on your video, if
It
possible.
says that you cannot start your video because the host has stopped it.
Oh, is it? Okay, just a minute. Let me check. Yes. Now. Okay. Now all of you just on your video. Yeah. Okay. So how was the session? Just try to fill the feedback form and give your suggestions so that we can improve. So our main objective is not to teach Python really. We want to go beyond that one. Fine. So Alka ma'am, thank you for joining. Okay. Thanks to all. Fine. Thank you. Now I can go. Okay, so if you have any doubt or any query, then we can join at 7 o'clock today. Fine. Thank you very much. And all the videos will be shared with you. Thanks. Okay, now the meeting is done.
Thank you, sir. Thank you to all
Thank you.
participants.
Thank you, sir. Thank you, ma'am.
Thank you, sir. Thank you, ma'am.
Thank you, sir. Thank you, ma'am.